This is question 13 from section 1 of the 2004 BMAT, and in this question we're asked to judge whether a condition is necessary or sufficient. So let's see what it is in more detail. So the passage is about the connection between the structure of ice and the existence of life, or at least life as we know it, and we're basically asked if one is a necessary or sufficient condition for the other. So let's read the passage first and then we can come back to this. So it says, when water freezes, the molecules form a very open structure, and that's convenient for the evolution of life. So these are all going to be factual statements. This is a bit like a draw conclusion question, except we know the conclusion is going to be that it's necessary or sufficient, or both or neither. And then the next couple of sentences say, this structure makes ice less dense than water, which means it floats. And for most materials there's a tighter structure, so the solid doesn't float on the liquid. And it gives the example of solid iron not floating on liquid iron. Then it says, when the oceans freeze over, ice forms an insulating layer on the top, and that prevents heat leaving the water below. And without this insulating layer, the ocean would freeze solid from the bottom up. And then it says, then it connects it to life, so it says, since life began in water, it wouldn't exist if the oceans froze. So let's try and simplify the structure of this. This first sentence is just introducing the issue, the rest expands on what it means. And there's basically a couple of steps. There's the structure of ice, which leads it to float, and that prevents the ocean freezing. And then there's the connection between that and life, which is that life wouldn't exist if the oceans could freeze. So if we just do those, starting with, because we're looking for what's a condition for life, so we'll start with life existing as we know it. Well, for that to happen, the oceans have to not freeze solid, and for the oceans not to freeze solid, ice has to have a structure that lets it float. Why have I used this have to and has to language? Firstly, when we're looking for necessary or sufficient conditions, it's often useful to think about what has to happen if something else happens. And secondly, it's good to have the same language in both, because we want to draw a connection between life and the structure of ice, but there's this sort of intermediate fact, which is the oceans not freezing solid. So because we're trying to connect the two, it makes sense to try and use the same language in both, to hopefully make that simpler. So in particular, when we're talking about necessary or sufficient conditions, we're trying to look at the connection between this, the structure of ice, and life as we know it. We're really thinking about possible implications. So if the structure of ice implies the existence of life as we know it, then this existing is enough for this to happen. And so this is a sufficient condition for this. So if this implies this, if the arrow goes this way, then we have a sufficient condition. And if the arrow goes the other way, you can have arrows in both directions, but suppose an arrow goes the other way, so life as we know it implies the structure of ice is that it is, then if life as we know it exists, then the structure of ice has to be as it is, so that makes it necessary for this to happen. We could say this has to happen for this to happen, so that's why this is a necessary condition. So with that in mind, let's just judge which of these arrows we can draw. So does the structure of ice imply that life as we know it exists? Well, no, because just because it removes one possible obstacle to life evolving doesn't mean that it's enough for life to evolve. We might need other things as well. After all, there are probably lots of planets where ice has the same structure, but there still isn't life, or at least not life as we know it. So this direction doesn't seem sufficient. How about the other direction? If life as we know it exists, does the structure of ice have to be as it is? Well, we've got these two have to statements. We know if life as we know it exists, then the oceans have to not freeze solid. And if the oceans don't freeze solid, ice has to have this structure. So yes, that does mean if life as we know it exists, then ice has to have this structure. So this arrow works. So we're looking for something that's a necessary condition, but not a sufficient one. And if we look at the options, Basically, we're given two, and we're allowed, so necessary and sufficient, and we're allowed to choose either one or the other, or both or neither. And choosing just option 1 corresponds to the answer being B.